Hey guys, today I want to show you how you can use the sample program library in RobotC to help learn basic coding. So I'm going to open up RobotC. You can either open your graphical version or the straight 4.0 version. And you see I have mine set up with the graphical block codes out here, but when you have this open, go ahead and go under File and go to the Open Sample program. Some of you may have already seen this and have browsed it, but I want to make you aware that RobotC does come with a library of sample programs, both in the graphical phase as well as the text script phase. So I'm going to go up a level here just so you can see. Under sample programs in the RobotC program directory, there is an area. I'll go up one more here. There's an area for graphical, and there's an area for Vex2. So you'll use either one of these, depending which type of program you want to pull up to look at your samples. So I'm going to go into graphical first. Look at the Vex2, and so you see there's a library of several different types of programs here. We'll look at the ultrasonic, and maybe I want to program to look forward until I'm near something. So I'll launch that program, and here you have the block code that's used to create that. Now, very important, make sure that your motor sensor setup parallels this sample code, but you can use this sample code and you can put it into another program if you need to, or you can build upon this program if you need to. So what's happening here is that we're running our left and right motors at a speed of 75, and we're waiting until our sonar sensor has a value of less than 15 centimeters, and then we're going to stop the motor. So very simple, straightforward program. If I wanted to look at this very same program as text, Graphical C does have a way for me to view that as text. So if I go onto View here, I can convert this graphical file into text. And now here is all that. Now this is the program configuration that was currently set up. And it might not be what your robot's set to right now, but so you'll want to have your configuration set up in advance prior to getting in here. But here again, you see that same program, and it's set in the script C. I now have two tabs up here. I have the C version that I'm in, and I still have the graphic version that I'm in that I can go back and forth at and look at. So if you're one who prefers to program with the graphical terms, you certainly may do that. Understand that there are some natural language script that parallels with some of these, but this is one way you can go about looking at your programs. Now I'm going to also open up another sample here. We'll go File, open a sample program, and let's go back out here. We're going to go up and look at the sample programs in VexNet 2. So again, these are RobotC's sample programs folder is where I am. We're going to go into VexNet 2, and we have a wide variety, in fact a much bigger library of programs to look at here. Maybe I want a line follower program that I can build upon, or I want to look at a bump and limit switch program, or maybe even just some very basic movements. Let's take a line follower, and we can look at line tracking with a single sensor, or maybe a triple sensor in line tracking. Okay, and it opens up the script code, and this is the configuration that it was built around. In this particular setup, they're assuming that we have three sensors, our right, our center, and our left. All are facing down, and they're programmed into analogs ports 1, 2, and 3. And we have a right motor and a left motor that's plugged into ports 2 and 3 respectively. So this is just call out comment code up here. It's telling you about the configuration that was set when they built this sample program. Yeah, of course this will be modified based off of your motor and sensor setup and go forward. Now looking at that program, they start the main program here, and what you'll see is common is a lot of times we actually begin our program with a wait. We haven't done that, haven't introduced that concept to you guys yet, but they are building in a 2-second wait here before moving forward in the program. And then it initiates a threshold where the sensors are basically taking a dark and a light reading, where we are defining the bounds of reflective light here. And this comment out here is telling us that basically adding those two values together and dividing by 2 is what's giving us our threshold value. Using the while true statement, or while 1 equals 1, as some of you may be familiar with, we begin our program. This piece right here, since we are not using the LCD outputs, you could remove this. You can leave it in there too. It won't affect your program. But we're currently not displaying those values out on the LCD. But that's what this does, is it puts those values out there so you can see it. But the actual meat of the program is down here with the if-else statements that come into play. And so, if this sensor is, what we're looking at here is if the right threshold, if the right sensor, or the right line follower sensor is greater than the threshold value, and that was the 504 up top, and we're going to run the left motor, and it's going to counter steer to the right. If the line follower sensor center was greater than threshold, we're going to say go straight, and we're running both motors here to allow that to go straight. And then if the left sensor is seeing dark, that it's going to be greater than the threshold, and so it's going to counter steer to the left, and so we're running the left motor we're running the right motor to bring it to the left and bring it back online. So this is a very simple code that you can integrate into your robot to get some base line following, and this may give you something you can build off to make a much more complex robot. I encourage you, do take advantage of the sample programs just to learn some of the basics of coding, and to also help you troubleshoot some of the things that you might attempting to do. There's a great library of resources that are available for you right here in the RobotC program. Okay, good luck with your robot.